Hey guys, in this video we'll be writing an image to ASCII art converter. So basically you give an image and it converts that into an ASCII art, and we'll be writing this in Zig. I've been writing most of my projects in Zig now. Not most, I would say some, but yeah, I like the language because it's very low level compared to Go. But I am yet still I am yet to explore what Zig provides. You know, like the complete thing, what it does. So yeah, I think we'll start with this that we'll take an image and we will convert it into an ASCII art kind of thing. I know zero about this, so we'll just start with that. I know that there is an I know that there is a library for Zig to convert the image into raw pixels. I know we are going to be using this, but I'm not sure how we are going to be converting this into an art because there's going to be a lot of pixels. So yeah, and we'll just get started. For this, I'll just open the Recreational GitHub repo. If you have not um, seen the repo, it's just a repo which I've created, which where all my code content of this YouTube channel is going to go. And do give a star if you want to follow what's happening there. And yeah, let's start. I'll just do image to ASCII. Let's name it as image to ASCII. And since it's Zig, you need to have Zig installed. So in my case, I already have that installed via brew install Zig or Ziglang, I'm not sure. Yeah, so it's Zig. You can just brew install Zig. Um, so I can just do Zig in it, which will create this boilerplate for me. But now I can just do Zig run src slash main.zig in order to I think I need to build it first. Just build it. So when we build this, right, we get an out directory, zig out, I guess. I'm not sure of that. Yeah, so we can just call zig out bin slash whatever this is. So this is actually that's printing inside the boilerplate. So for now, we can go inside, just go inside tmarks for a bit. Yeah. So in src, I think we need main.zig. I'll just remove all the test cases for now. So let's clean this up. So we can just print. Um, we print it. Debug.print. You can just pass an empty arc. So in Zig, semicolon is a must. So just don't want to run this Zig build and then calling this. Yeah, it works. It says hey. Just don't want to run this command again and again. I'll just create a make file for this. I need a file. So with make file, right, you can just say, you can just give command shortcuts kind of thing. Kind of a, yeah, you can say an alias kind of thing. So for build, I'm just going to say zig build. For run, I'm going to say, we can just say zig out slash bin slash ASCII. We can just run this, but I'll just say zig build and then run this because we need to build every time we make a change. So now I can say make run in order to run this, or make build just to build that and update the binary inside zig out. So yeah, so there's a root.zig. I don't think we need that right now. We'll get back if there's anything to do. So right now, zig, I think we need to add this zig img. Before even that, we need to pick which image we are going to convert. So I'm going to take some png image of, let's say, should we take some png image? So which one should we take? I'm not sure. We take the Linux. Let's do that. let's say the Linux kernel's image. But not sure how this will be rendered. I want it with a, so this one is transparent. I want it with a white background so that it's, why is everything transparent? I think people search for transparent mostly. Let's see. Actually, we need to save this in our code base so that we can refer it easily. I'll just go inside this, just a Linux. So if I refresh this, I have this linux.png here. So now I can refer that. So what we're trying to do is we're trying to get a you know, an ASCII art of this. So ASCII art in the sense when we run this, right? When if I run make run, I should get an ASCII art here, which not a, which is not 100% similar to the image, because I don't know if that's that easy to achieve in this small amount of time. But I think we could try at least to make it seem possibly nearer to what it is. So yeah, I think we have the image, so all we need is the library. We need to just install this. So first thing, let's go through the package manager. Let's fetch this, and then we need to inside build.zig, we need to do this. So build.zig is where you give the options to this. So this is also boilerplate, but you can update this by saying that I also want to include this dependency, which is zig img. So now if I run make build, it should also consider the zig img, and I think make run should work. Now let's verify this by calling this in zig img, right? Zig, yeah, there is a zig img. So let's print the value of this zig img. I'm not sure if we can do this. I'm still exploring this. No, we can't do this. So how do you take types? Type of img. Um, okay, let's do any, I think. Yeah, it works. So we are able to import this, and we're able to run this. So now what I want to do is I just want to, so let's see how to run this. It says PNG supported. So we just need to read it. We don't want to write it. So partial write doesn't seem to bother us. So we're able to read that, so that should be fine. How do I use this? Yeah, okay. Yeah, from a file path, let's use this. So we can just take this. So let's say Linux. We can do something with the image. I think let's see what the image has. Some file path gives us an image. So this, okay. Does this have any, how do I do tags? Tags. Is there any method which is, so I see some, I think this works, right? Raw bytes. So this returns the pixel data as a constant byte slice. That should work because the byte slice is anyhow going to be between 0 and 255, I guess, because there are 256. So let's actually see if that is working. Let's just do any, and then let's do image dot, we have to do it here, image dot, you do that. Wait, what was it? Raw bytes. Okay. I see lots of zeros and yeah, so this is a raw pixel data which we are seeing. We need to condense it so that um, this doesn't take this much scrolling to see all the data. We just need a small art form, right? It's too much, it's too big because it's each one pixel. So we need to maybe take uh, what do you say? Maybe 3 or 4 pixels at a time. So what do you call that? I think that's scale, right? So here's what we want to do. So I think there are multi-layer comments. Okay. Uh, so first thing is we want to, before even scaling this, let's decide on symbols. So because it's an ASCII art, we need to decide which symbols we are going to show for which pixel values. And pixel there are 255. We don't want to show 255 symbols. We want to show maybe some 5 or 6, and we just need to um, do that. So let's say, what do people usually use? I know they use star, slash, dollar. Let's just use these random symbols. But I think this can also be optimized. I know that, but let's just use this for now. So for so there has to be a range. So 0 is completely white, I guess. Um, okay, 0 is completely black. Yeah. Okay, yeah. If you see the image, right? So this is black and this is white. So 0 is completely black and 255 is white. So 0 is white, black, 255 is white. We want to decide between this. So let's say for so we have 255, which means we can divide it into 5. Let's say 6 symbols for each 50 range. So 0 to 50, then it's going to be around black, right? Do we even need to use black here? That's the issue. Like, hmm, let's use star for now. And if it's 51 to 100, it's going to be at, not at, let's use equals. And if it's 101 to 150, going to be at 151 to 200 plus 201 to 255. We're going to go, we have to use dollar, right? So let's do this. First, let's, so we get cons u8, right? It's a list. So how do we do looping in Zig? I know, but I'm not too sure of. Oh yeah, I think you can just do the closure kind of thing. Can I do for image dot raw bytes? This will return me pixel. Can I do this? Okay, this needs to be here. No. Maybe I can just say pixel here. So let's see. Yeah, I think that works. Now, so we want to build another cons u8. Like, let's say, let's call it as ASCII. Sure, how do you define this? do you say that? Right. So can we do empty? Yeah. So we can just say ASCII dot. Can we do append? What do we append? So do I get an index? Because I think we need to um, allocate an space for this, because it's not a static array. We don't know how many it has, but we could condense. That's an optimization. We could condense that. I think this is a slice. Um, so we have a slice. I think loop index is what you're looking for. Can we do? Okay, I think value and index comes here. Let's. Okay, that is what is returned by this raw byte, I guess. So what I'm looking for is append to slice and see. Oh yeah, I think there are different types of array lists. I remember now. So we need to, yeah, we need to create an allocator, and then we need to create an array list, and then pass the allocator to the array list so that memory is allocated according to it's mapped to that array list, and then we need to call dnit on this array list. So let's do this. Let's get an allocator. So this is a general purpose allocator which we can allocate and deallocate multiple times. Wait, is an allocator? Okay, there's already an allocator here. But this is, let's do allocator. What we want to do is we want to create an array list. Okay, let's do ASCII. I think that we can just say std dot array list. Okay, it should be u8, right? Const u8, I guess. Is it dot init it with the allocator, and we can just do we do differ? Yeah, we can do differ ASCII dot init. Hey, does this even compile? It won't. Array list dot init, right? Let's go into this. Wait, how do I create this? I can just say list is empty, and then we can name it and then allocate. You're saying, can I do this? For this, can I say ASCII dot append? Yeah, you need the allocator. And just view the allocator here and then the pixel. Are you saying you can do this? You have to try here. Yeah, it works. So finally, let's comment this. I just want to show the length. I don't know if I can do that. If I can do ASCII dot items. Not the items, I just want to show. This is not length or size, I guess. Length. Maybe items dot length. Yeah. Okay, it's 360,000 pixels, and we need to compress that in a way that it's we are able to see that. So we have to take blocks of pixels, and then um, take an average of that pixel, and then take that average value, go and create the replace the image. Maybe we can do that. Or for now, I can just say I don't want to append this one, but can I do switch pixel? What do I do pixel? I just want to see if it's 0 to 50 then. Okay, but still I want to let's see if there are any in the. Can I compress this? What's this on? So maybe we need to. Just thinking switch case with conditions inside. Okay, let's go here. Okay, I could do this. Then I could do 50. Yeah. Right. So it's 3 dots. If it's 0 to 50, then I'm going to append not the pixel, but what we decided, which was star. And if it's 51 to 100, I'm going to go with equals 101 to 151. We're going to do at 150. 151 to 200. We're going to do plus, and 201 to 255. We're going to do hash. We might have to change this. The symbols which we are assigning. It works, but should we print it? It's not even recognizable because let's just print that. Okay, there you go. Why am I getting? Maybe it's the ASCII code, right? What's 42? Okay, it's for the asterisk. So I want to display this as a string. So can I do? No, I can't do that. Let's do as a string. So if you see this, it's not very understandable. This the star is completely black. So anything other than this is a pixel, which we are. So for the reference, I want to show the actual image. I'll just show you the actual image. So this is actual image, and so we have to compress this so much. Compress in the sense we have to scale this down, um, so that it's easy for us to. What do you? Let's. Should we take a smaller image? Let's try doing it with a smaller image. Very small. Let's go Pikachu. Need too complicated. How do I even search for this? Could you just try this? For example, if I take this, right? Do one thing. Just take this. And then the screenshot is anyhow saved, and I'll just do Pikachu.png. If I open this, yeah. So let's try mapping this instead of the line. How much is the size of this? 200 pixels. If you see, we are giving hash because it's white background. We are getting hash. We need to scale this down a lot. Actually, what's the length of this? It's similar length. So we have to scale this down at least to maybe 1000, 2000 pixels. Let's see how to do that. If I, what's 320356 by 50? So we can take 50 pixels as a single pixel. We can do that. So for each, so when we're going through the raw bytes, we just need to collectively we don't need to do this for every pixel. We can just draw this for each of the 50 pixels, right? And take the average of them. So let's say average, I don't know. Can we do this? Yeah. It's been too long since I have written in Zig, so it's a bit confusing. So let's say the average is 50, not the average, but let's say the count. And we start with, we start with 0, and then for each 50, right? Then we have to do that. So let's go. Let's say id is 0, and if it mod 50 is 0, then we are going to do this, let's say. Right. And we have to do it, increment this. So I can just say, I can just say count here, but just do that afterwards. So now let's see the length of this. Like that. Is this how we do it then? I think there are different types of ints. with the bit sizes. Yeah, this should work, right? A32 should work. The mod 50, what's the problem? I don't know. Reminder division with, okay. So this is comp terminate, they're saying. Oh, okay. Okay, is there, oh, okay. I can do this. Okay, so let's print that out. It's something, but let's actually give empty string here, or a blank string for completely white. Okay, it's just not very, even if I resize the screen, right, it's not very good. We need some tinkering again. So this is for this image. Let's try with the Linux image. Or should we have to take average, right? I forgot to take the average. Yeah, we have to take the average. So if else I would do this, and instead of the pixel value, I want to track the current average value, which will be 0 at starting, and as it goes, average or current average, not the current average, okay, current average plus equals what is it equal? Let's say pixel current, what do you say, um so when you compare it, right, and you have to switch, you have to check for current sum divided by 50. Oh, come on. Is there anything? There's an else. So this is so I think we need to for every 50, I think we even need to add a new line, right? Try doing that. Okay. Why lot of new lines? Okay, where did I add this? I needed to show, let's say, these many rows and these many columns, I think. So let's say I want to show it in 20 rows and 20 columns. So let's say I want where row, const rows is 20 and the columns is 20 as well. So then we should scale the image so that it fits under 20 by 20, right? So in order to do that, let's say I have let's say I have like n pixels. Um, let's say I have 320,000 pixels. I needed to bring that into 20 into 20. And we need to pick the important ones. Let's actually check how this works. How image to ASCII works. Yes, this is what you're doing. Yep. Okay. So it's 50-50. But I don't know how do we do that? Um right now if you see we have too many new lines. Let's remove that. Let's put this dot instead of hash. This doesn't make sense. Which image is this? I'm not even sure. So we need to let's say this as count. You can say this is 20. I think I think it's taking 50 pixels, but I think we need to take the 50 columns as well into consideration. How do we even do that? We need to get the dimensions of the image. We need to do that. Right now, the image we get, it's quite not good. So yeah, I think it's mapping this thing. We need to. We need to do. We need to. So what? I'm not sure of what exactly the rescaling means. But we need to resize it. Do we need to resize it? Okay, we can try resizing that, right? So instead of trying to do that pixels, what if we resize image? Resized image. We saw a resize somewhere, right? Maybe a resize. And I think we need some other library. Is it img? Maybe the img works. We have to load it. Do we have to load it? I don't want to crop it. Row byte size. Okay, for each row, asking. So what if we get the row size? So let's we do get row size, the row byte size. So it's 600. The total, there are these many. Okay. Because I think we have scaled it, we don't want to do that now. So let's say I don't do anything here. Just switch the, just comment this for now and say pixel here. What are we missing? So it's 360,000 total pixels and 600 pixels per row. So it's 600 and 600, right? Yeah. So it's 600 into 600. That's the exact number of pixels. But how do you even reduce the scale so that we need to resize it, I guess. So let's try one thing. Let's resize this online. And then we can try to uh, bring that to see if the mapping is working. So let's try Pikachu. Want 70 into 70. Okay. It's JPEG. And I have to do JPEG to PNG. Do it. Replace. It's resized. So if we try to let's just run this. No, it should be much lesser, right? I think it's resized, but do it again. So it's not resized. Converting it, I think it has. increase the resize time. Let's replace that. Yeah, this is 17 to 70. 14,000. I think let's try again. Let's go here. I think yeah, it should be fine. 17 to 70. Let's see the items. I think the display, I think we should change that anyhow. Oh, if see, I think it's you can see this, right? We can see that we need to resize it a bit, but I think this is great. You can see the shapes and all coming out. So I think we have to resize it after all. Let's try to do a resizing image resize. Zig. Oh, I'm not seeing any zig here. How do I even do that? Let's do zip signal. Okay. So it's the same, but how do we use this? Just want resizing. We have resize. Yeah. Is there any documentation here? No. Okay. Yeah, we have need searching for something related to resize. Is there image? Okay. The image has. Let's go to R. Yes, we have the resize. Let's go see what it takes. Allocator out method. Wait, how do you even call this? Okay, okay, yeah. It takes rows and size. I think let's just add this. Is it signal or yeah, it's signal, right? So let's come back. Let's add it. And in build.zig, let's just put this. Let's build this first. Upgrade. Zig. Is it update or upgrade? Wait, why do we need the Zig dev version? Why do I need a Zig dev version? Um, you know what? Maybe we can install it as a Python library and then just call the command, right? And then just do that. I think for now, I'll just do that. Let's try to install this. I think I need to import that in this thing. So let's just install Zig version. What's the version? Let's install this. And let's go here. We need it for Mac. Yeah. But I don't know how many things is going to break. I'll just revert it if this is not if this breaks anything. I'm not sure how to uninstall this. Yeah, okay, here's the zig. Wait. Okay, this is a release, right? I guess so I have this in zig. Let's call this zig dev. And there's a zig inside that executable. So here instead of this I can say zig dev -zig. Does that work? Okay, there's this. Just have to allow this here. Yeah. So in the make file, I think we just need to run zig dev /zig instead of the zig command. And then here I can just do make build. Yeah, I said it's going to break something. No, it breaks something. Wait, what's this mean? To yeah, it's this version, but what's the issue here? Okay, is it the zip? Okay, let's remove the zip cache. Maybe it's trying to use something from there. No. Why would this even throw this? Okay, did they change it somewhere? But okay, I think some modules which we have, right? The zig img, I think, yeah. So they are using some you know, they're using the keywords which are not supported in this dev version. So there's a mismatch between zig img and so I think probably we have to remove the zig img and then just use signal, I guess. So can we what are we doing zimg, sorry. We're just loading it and trying to get the pixels, right? Can I do that here with we get the pixels? We have to see the documentation. Image. I think this is it. Let's try to do that. Let's comment this out. Comment this out. And let's do zip build. Sorry, make build. But I think it will fail because we need to remove the usage here as well, but we need to somehow call signal, so that let's first import this. So can we, do they have the examples, right? Let's try that. So let's go with image demo, have the signal and image is this. And now we want to load the image here. Uh, isn't it? Wait, resized. Where's the image? Okay, let's take this as well. We need RGBA, but do we need even? We don't need RGBA, I guess. We'll just see what that is. And args, I guess. The iterate allocator. So let's actually see if this works by printing out. Let's just try to build this. Just putting it all in one file. It builds. So we shall we try to load this? Png, and can I take this image? It is LSP loaded. Yeah. I need the pixels. How do we do that here? As bytes. So let's do image dot as bytes. I'm not sure if it has what type it is. Yeah, it's directly, it just gives us the list or the array. Let's run it. Don't. Pikachu.png. We have a Pikachu, right? Yeah, because we're running from make, I think it should be. Yeah, I think as byte. What if I do any? Yeah. So that works. We're able to load it. So here I think um, we could do image dot as bytes, and then we need an yeah, allocator. We need an allocator as well. So what is the problem now? We need to resize it. So let's do okay, we kept it for ASCII, right? So I think that's the reason. I can just do ASCII dot items. Yes. Why? No member called init. Not showing any error as well, that's the problem. Why does this fail with no named, no member named init? Why? I think I got this error before as well, but how did I solve that? I don't know. Let's see. Wait, did we do this or this? Let's put the allocator here. Yeah, I'm able to see this, but I think we need to resize this first. So let's do one thing. Let's pick the Linux image. Let's do this. Before even doing that, we just do resize. How do they did that? Resize image.gpa. Hmm, okay. This is a resized image. I want to bring it to 50 by 50. I don't know if I can do that because it throws this comp per minute thing. We can do that. So instead of the image, we have to do the resized image. So we have to do resized. Why is not able to resize this? Can I do 20 by 20? It all plus. What is the plus? Around 151 to 200. Let's do pixel mod. Wait, is it even possible? Hmm, I think it's all zero. Doesn't allow me. So when we resize the previous thing, it worked, right? Maybe we need to just print the pixel value here, right? See the values. Wait, it's all 170. Wait, is it resizing it good enough? Let's try. Why is it on 170? Wait, is it because we are using RGBA? Can we not use that? I just need to um, RGB. Okay, we create an image. And we do RGB, I think. What else are there? I think RGBA, signal RGBA. The black. I just I guess I'll just go back to because that worked well for me. I'll just use CLI itself because it's not that good. It's from me, and it's asking me to use a dev version of zip, which I don't like. So I'll just go here and just do zip. And I'll go back to main, and I'll just do undo this until the part where we didn't start using signal. If you see, if I make run here, okay, I have to do make build first. Wait, we build it, right? Okay. For what? Should I modules? I'm not using that anyway, right? Signal. Yeah, if I reduce this to, let's say, if I image resizer CLI Mac. Right. Do we have a built-in thing for Mac? I didn't know this. Let's go into this. What do I want to do? I want to resize it. Width. Let's actually try going to 20 Pikachu.png. To 40, 50. Oh, it was 70, right? To 40. 365. Too big of an image. We have to reduce it. But 70 was very good. Just the size of the image was size of this thing is huge. We need to reduce the thing. If we do that, I think it should be good. Too many dots, right? So let's try about 100. 70 looks like the sweet spot at least. So let's try this for Linux. Yeah, I think 70 is great. You can see this. It's actually great. It's just that we need to cut it down into little lesser characters. It's great. But see the this actual image. We get the penguin, we get the Linux thing. It's just the shift has to happen. But how do we do that? That should be only some way to do that. So right now we are just appending that. So we must have some condition before even appending that pixel, right? Maybe we can get the row width. We just need to reduce the row width, right? We don't need this much. Let's say I get the row byte size. Fonts row size. It's going to be image dot row byte size. And then keep some counter here like we did before. And if so, if it mod, I think it's mod it mod 50 to 70, and then we can just continue. Not sure what I'm doing, but let's see if this works. Yeah, now I think we get this inside the, see, it's great. We get a fixed set of rows, right? If I increase that to 170, I should get a bigger image. Yeah, the bigger image, but it's not that clean. 70 is always clean. Is it 70, 140, 210? Is it that? Let's see if 210 works. Yes, works. Works. What if I am here? Let it make it doesn't work because the terminal size is too small. For me, this is fine. What if I do Pikachu? Yeah, beautiful, right? It's really nice. I thought it would be worse than this, but at least by seeing this, I know the tail, at least it looks like Pikachu, right? Let's try something else. So the main reason is that this thing, the image, right? It's very, you know, what do you say? Compressed, or it's very much smaller than what the original size is. So we need to do that for every image. So why am I saying that is that, for example, if you take some image, right? If we do Modi, um, let's do zig lamp, right? Let's do this logo. Need a clearer one. Yeah. If I take this, right? If I put this here, it's WebP. I need PNG. Actually, let's do the Golang gopher, the blue thing. Yeah, let's do this. So this is a PNG image. If I do gopher, right? So do you think this works? Do you think this image will get? It won't, because the aspect ratio is too big. So we need to run an OS command. How do we run shell or spawn OS things in? Uh, it's like this. Um, yeah, I think we can just do this. Before even starting anything, let's try to do this, which is pips dash z70, and I need the file name. File conjugate is over. How do I put that here? Can I do this? Wait, can I do this? Not sure. I was actually not sure if I could do that. So let's see. So right now the gopher, right? It's this. This is the size 98896. If I do make run, I make. I'm gonna make run in another one. Let's see if, yeah, I know it throws an error, but it's not going here. Something wrong. How do I concatenate two strings sig? So can we do plus plus? If I do make run, right? And then if I do this, it should decrease the size. File not found. Gopher.png. Wait, where it is running from? Okay, let's do this. dev slash. Let's see if absolute path works. How about Pikachu? I will not found. Let's try this one. So here again we need this and the file. Let's see. Yeah, I think that works now. And let's try for the gopher image. So what I want to see is the size here is 98896. I want to see if that gets reduces because the aspect ratio is reducing. You see the now it's reduced because we ran the zips command from zig, and now the output should be somewhat reasonable, I guess. We know this is much bigger, huge image, right? I think width is too much on this. Let's try some another picture. Let's try again. Right. Still, I think we need to reduce that. I think the width is too much on something, or something is missing. I'm not sure. What if we? Okay, we are not doing 70, right? Are we doing 70 to 210? I think for each image, the parameters are changing, but it shouldn't happen usually. So if I try to make it even smaller and smaller, see, I think the problem is here where we are trying to do this. Some images doesn't take 210, some images might take 140. But yeah, maybe it's asking for, let's say 350. Even on the size actually. Yeah, but we need to control that. No, I think this doesn't work. But it works perfectly fine for, let's say, another non-gopher image. Let's try for zig. actually. PNG. Yeah. If I go here, still this is not that good. So again, this thing is changing every time. The parameters which we need to do for this file. There are too many pixels, right? There should be these many. Make them 70, for example. Where is these many pixels? Just need to find some perfect parameters so that we can just put this. Try again. This. See? This is great, right? This comes out perfectly, but some images don't. I don't know why. So I think, yeah, this is what I've been aiming, and we have got what we wanted. So thanks for watching, guys, and see you in the next video.